Todd Frazee, and this is the tutorial for doing the 4th axis machining on a 7322 REV 0 part. Now what I have here displayed is the SOLIDWORKS model. You're going to be able to import directly into Fusion. This model that was developed in SOLIDWORKS is a really common thing you have to do if you work for a job shop. You're not going to have control over the model that's received, and you wouldn't necessarily be modeling the part. Now if you look at these features, you should have already modeled these features because they're required for the stock, and they should be identical to the model. And we're going to import your stock model into this and the 4th axis for machining. So here we go. Okay, so what we're going to start with is you're going to download the SOLIDWORKS file to your local system, and then you're going to select that file wherever you've saved it. So you're going to go and make sure it's on and you're going to select from the file where you saved your SOLIDWORKS file. Now it may not display on here unless you've opened it already, but it should be the 7322. I believe in the assignment it has underscore R0 on it from SOLIDWORKS, and we're going to go ahead and hit open. Make sure you save it somewhere where you know it's where it's going to go, and it might take some time to process. Okay, once the upload is finished, it should appear on the left. Sometimes you need to wait a little bit for it to process. Okay, so once it's fully processed, it should look like this. You should be able to open it, and you should see this model like this. You notice the feature should be the same as your stock as you've prepared already. There's this boss and then this pinhole. So when we line up our other files, we want to make sure we're aligning it to that index feature. First thing we want to do is we're going to change the name of this because it's a generic name, but we want to use our naming convention. So right click on the name of the file, and you're going to change it from what it currently is to rev underscore 0, and then your first initial and last name. And remember, for this to take in Fusion, you have to hit the enter key, and the new title should show up here. Okay. That way we're consistent in our naming convention. Okay, the next thing we're going to do is you're going to pull in the stock model that you made before, and that should be the 7332. Okay, so it's 10 number digits difference, and you're going to drag that file in, which if you left it at default, it's going to show the vices you were using. Let's expand the menu and go ahead and hide the 2 vices so that all we're looking at is the model itself. And let's expand the bodies. And what we called stock on the 7332 was actually the stock to make the 7032, and we're going to make that invisible. Okay, now let's move this around so we can see it. It looks like our pinhole is not in the same orientation, so let's rotate that 90. Okay, and that should line up. And now we're going to hit OK, and we're going to take this, what we see here, and we're going to go to Assemble, and we're going to make a joint in between the center of the boss. Make sure you're getting the surface so that we don't get the chamfers, and then the corresponding spot on our model. Now it looks like mine did a flipped orientation. Just check the flip box if yours does that. Everything should line up. You should see witness lines of the finished machine part in there, but you shouldn't see any double lines around here, otherwise you have the alignment off. Okay, we're going to go hit OK. Okay, so now what we can do is we can toggle the 7332 on and off as our stock body that we're starting with to make this part. Okay. Now, and we're not going to use any of the vice information there. Okay, for now, let's go ahead and make that entire model invisible. Okay, for now. And we'll go ahead and collapse down the menu. We'll open that back up when time's appropriate. Now we're going to bring in the fourth axis with a custom fixture that we're using at Sierra. We're going to hold this with a drawbar. So we're going to bring in your fourth axis for the assignment. It should be attached to the assignment. And we want to orientate that as if it's on the table. And in the orientation with this pinhole on the top. So, because that is going to register with this dowel pin in the fixture. Okay, that's going to be clocked vertical in the machine. Okay, so when you get this in here, you might have to unground it from parent. I'm not seeing that on mine, but if you see a little anchor sign, you need to right click and unground it. Okay, we're going to move this fixture over so we can look at it. And the first thing we're going to do is we're going to rotate it in this axis. I think it needs to go 90 degrees in my case. And that puts the pinhole in the same axis as the pinhole in my part. And then we're going to hit OK. Now I have this drawbar set up so that it has a length that is extended. So we can use different length parts. So let's go to inspect and see how long our part is. So the distance we need is from the face shown here to the face that's going to sit on the surface of the plate. And that is measuring as 2 inches 510 thousandths. Okay, so we're going to go ahead and set this number here to 2 inches 510 thousandths. That should put the bolt out the proper amount for what we're actually mounting in there. Okay, now we're going to go to assemble, and we're going to go to joint, and we're going to pick about here. We want the snap point to be at the center, but we want to pick this forward face here of our fixture, and then the corresponding face on our model. Okay, when we're all said and done, you should be able to zoom in and still see this little chamfer here. We'll hit OK. Okay, we're going to set this at 2 inches 510 thousandths. Now we're going to go to assemble, we're going to go to joint, and we're going to join the center face of the plate with the face center of this face here. Make sure you're getting the correct edges. If you do, you should see the little 10th thou chamfer on the outside edge present, and hit OK. So we've got our bolt holding this on through, and our pin should be interfacing with the plate. What this plate does is it helps us index it, so if you don't finish in class, you can take this on and off the machine. It also allows, with the clocking and the pin, it also spaces this away from the body so that we can get tool cutters in without hitting the steel platter. Okay, so that's our assembly, and now we're ready to go into the machining side of things. Okay, so we're going to go ahead and make sure you're saving. And we're going to go to the manufacture mode. And it's going to ask you, one or more inserted designs have setup operations. You can insert into this data now into your document. If you choose cancel, you can add it later. In the browser, right click on the inserted design and choose insert manufacturing data. We don't want the manufacturing data. That is the manufacturing data for making the stock material that's embedded in the model of that. We don't want that brought into this document. So we're going to hit cancel on that. And now we want to mess around with the models here a little bit. So on our configuration, let's expand these so that we can see our 7332. And we can go ahead and make the 7332 visible, and then we're going to toggle the body on and off as we need it for this operation of the 7332. So now let's go ahead and we're going to create our new setup. So we're going to go new setup, and it's going to default to doing the entire object, which is not what we want. We're going to select the model, which is going to be the finished part. Okay, and that is our new model. And we're going to go to stock, and we're going to make the 7332 model visible, and we're going to change from relative size box to from solid, and that'll allow us to select the 7332 model as our stock. All right, now we can go back to setup, and we want to set our origin. We need to set it in relationship to the center of the fourth axis for these commands. So what we're going to do is we're going to go to z-axis plane and x-axis. And if we had the table here, we could select the table, but we're going to select the bottom face of the rotary because that's what we know is going to be parallel to our table. And then our x-axis can be anything along the x-axis of the rotary. And so that's the correct direction, except for our z-axis is in the wrong orientation for our neutral position. So we're going to flip our z-axis so it's facing up. Now our origin is going to be a stock box point, and we're going to pick the one that's in the center of the face. Okay, so it'll be hidden underneath this nut that's holding the stock on. So this is how your origin should look. This is a must for some of the 4-axis commands we're going to be doing in this project. Let's go to post-process. We're going to call this the part number 7322, operation 1, and then our program comment should be op 1. And our work coordinate system we're going to use is 2. This will output as G55. We want to do this so we don't mess with the other classes that are using G54 a lot, or any of your G54 offsets for 3-axis vice work. So it's really important we put work coordinate system 2 here. Okay, now that we've done that, let's change this to op 1. And then let's go ahead and put some notes in. So we're going to go to our edit notes, and note number 1 is going to be WCS G55 XYZ origin. Center of left cylindrical face of stock. Okay, 2 is going to be draw bar torque to 60 foot-pounds. Okay, that's a lot more than we're doing with our vise. We want to make sure this thing is clamped on there pretty tight. Okay, we'll hit OK. We can go ahead and actually hide the 7322. See how it's now in yellow showing where the stock is. So we can kind of collapse everything that has to do with the 7332 model. We can collapse that down. I would suggest that our first operation is to cut the flats, these hexes. That'll reduce the material and we will have less clearance issues when we cut over here on the right. We're going to go to 2D. We're going to go ahead and use a 2D contour move. And we're going to select from our library our face mill. And we're going to keep all our standard default speeds and feeds. And under multi-axis, we're going to keep everything at default here. But in order to enable the fourth axis, we need to select this tool orientation. And so our origin stays where it is, but our tool orientation, we need to tell it how is it going to rotate for us to do our cut. Okay, so to do that, we're going to select what face is normal to what the tool spindle will be when it rotates. So we're going to pick this flat with this shape on it. And you notice that now the z-axis is now turned normal to that surface. So any 2-axis command we do will be with the tool orientation. It will clock it, and this is our 3-axis plus 1 move. Okay, and we can select the x-axis. It's not moving because we're not using 5-axis. So you can select it. It shouldn't be any different than what we had. And you can change the origin, but we're going to leave it at where it's at default. And that will put our spin center along the x-axis here. So now we're going to move on to geometry. And we're going to select just a single line. We don't want a chain. So we're going to go to a single segment and we're going to select this line. So we want it to cut on the opposite side of that line. It's going to start towards us and cut away. Okay. And so we're not going to run into anything here, or we shouldn't. If this thing's dialed in, we shouldn't be hitting this cylinder here. We can cut a little bit past. Now, if our operation's off a little bit, yeah, it's going to hit that. All right, so once we've set that parameter, we're going to go ahead and hit OK. And then we're going to go to the Heights tab. Now, we can set a lot of this at different heights. Right now, it's defaulting it at the radius of our cylindrical surface. I'm thinking that we're going to want that a little bit higher. We don't want to hit any of this fixturing work. So let's set our rapid plane. Let's do 3/4 of an inch. Okay. And so when our tool comes down, it's gonna start slowing down at this plane here, so that we're sure we're not hitting this outside diameter. I don't think we would, but that's going to give us a little bit more reaction time. Now when we retract back out, it's going to go to this other plane that's in a mustard colored. I think that's all right because it's actually just pulling back up before it moves on to something else. Okay, and we're going to go to the Passes tab, and we're going to put in Wear Compensation. Okay, so we're going to leave a lot of this at default. I don't think we need to do a roughing pass in the X direction, but I do think we need to do multiple depths. And let's set our maximum roughing depth, set 125 as our maximum roughing depth. And then our finishing step down, we're going to set that at 0.06, so that's going to be 60 thousandths. And we're going to do one finishing step. Yeah, finish at final depth won't matter. We're going to use even step downs. Okay, on our next tabs, we're going to put in a stock to leave. And we're going to put an axial stock to leave of 0, but our cutter has a little radius on it. So we need to put in an axial stock to leave of negative 0.04, which is a little bit larger than our radius. And we don't need either smoothing or feed optimization because those things are irrelevant for a straight line cut. Now we're going to go to the next tab. We are not going to do a horizontal, or we're not going to do a sweep angle at 90. We're going to do it 0. And our linear lead-in distance needs to be a little over half the diameter of the cutter. And we also are hitting a cylindrical part. So we're going to set that actually at 2 inches because it's a 3-inch diameter cutter. And we're not going to do a vertical lead-in radius. And then we're going to hit OK. Okay, so we get 3 passes, 2 roughing cuts, and then a finish cut.